Hello everyone. In this video, let us see about what internet topology means and let us discuss about its types, levels and applications. When we connect multiple computers or devices together to share data, we must decide how they will be connected. This arrangement or pattern of connecting devices is called network topology. Internet topology refers to the structure or layout of how the internet is interconnected. That is, how computers, routers, and networks are connected to each other to transfer data efficiently. The proper definition is that we can say internet topology is the arrangement of nodes like computers, routers, or servers, and the links like cables, optical fibers, or wireless connections between them in the internet network. It shows how data travels from one point to another through various paths.
Now we are going to talk about levels of internet topology. There are two levels in a network topology. One is the physical topology and another is the logical topology. Let us see what does the physical topology mean. So let us see the definition of it. Physical topology is a real physical arrangement of the computers, cables and devices in a network. It shows how devices are placed and how they are connected with wires. Okay, now we see about the example. Let us imagine arranging chairs in a classroom. If all chairs are placed in one straight line, then it is a bus topology. If all chairs faces one teacher in a center, then it is a star topology. Let us see the technical example of it. In star topology, in an office, all computers are physically connected to one central switch using cables. So this is the technical example of physical topology. Next we see the next level of the topology. Next level of the network topology is logical topology. Let us see the definition of it. Logical topology is a way data actually travels inside a network regardless of how the devices are physically arranged. It describes the flow of information. Now we see the example of it. Let us think of our classroom again. Student may sit in a row. Then it is the physical topology. So, but when the teacher sent the information, it was flow like a teacher, class leader and students. Then this is a logical path, not a sitting arrangement. So this is the logical topology. Let us see the simple technical example of it. A network may look physically like a star, but the data may flow in a straight line like a bus. So, it is the network topology, one of the type of logical topology. Let us see the very simple example of both together. 5 computers connected to a central switch. Then this is the physical, like a star. But the data flows one by one in a sequence. Then this is a logical, like a bus.
After understanding what is network topology and that it has two levels, physical topology which shows how devices are physically connected and logical topology which shows how data actually travels, the next step is to look at the different types of topologies used in networks. There are mainly 6 basic types of network topologies: bus topology, star topology, ring, mesh, tree and hybrid topology. Each topology has its own structure, advantages and disadvantages. Now let us understand them one by one. First, bus topology. In a bus topology, all the computers and network devices are connected to one single cable, which we call the bus or backbone. All the data from every device travels through this main cable and all nodes share the same communication path. This topology is simple, easy to install and cost effective because it uses very little cabling. But the main drawback is that if this single backbone cable fails, the entire network stops working. Because of this limitation, bus topology was used mostly in older Ethernet networks and is not common in modern internet systems. Now let us see a real-time example for bus topology. In earlier days, small office networks used bus topology by connecting all computers through one coaxial cable. Data would travel along this shared line and terminators were placed at both ends of the cable. But today, this structure is rarely used because it cannot handle heavy traffic and the whole system depends on that single cable. Now let us move on to star topology. In a star topology, every device is connected to a central device such as a hub, switch or router. All the communication between devices pass through this central point. This design makes the network easy to install, manage and troubleshoot. Because if one computer or one cable fails, it does not affect the rest of the network. But the central device is very important. If the hub or router fails, then the entire network goes down. Now let us see a real-time example for star topology. Our everyday home Wi-Fi setup is a perfect example of star topology. All your devices, your phone, laptop and smart TV connect to your Wi-Fi router, which acts as the central hub. If one device disconnects, the other still works fine. But if the router stops working, the whole network loses connectivity.
Now let us see about ring topology. In a ring topology, every node is connected to exactly two other nodes, forming a complete loop or ring. Data moves in one direction around this loop or in both directions if it is a dual ring system. The main advantage of this design is that it ensures equal access to the network for all devices and reduces data collisions because data flows smoothly in a fixed path. But a major drawback is that if even one connection in the ring breaks, the entire network can get disrupted unless a backup path is built in. Ring topology was once very popular in fiber optic metropolitan networks, but today it is mostly replaced by more flexible topologies like mesh and hybrid models. A real time example is metropolitan fiber optic networks and SONET or SDH systems. For instance, a city's telecom backbone may connect several base stations in a ring so that if one link breaks, the data automatically travels in the opposite direction and communication continues. This makes ring topology reliable for city level or campus level networks. Next, let us see about mesh topology. In a mesh topology, each node is connected to several other nodes directly, forming a highly interconnected structure. This gives the network multiple paths for data to travel, making it extremely reliable and fault tolerant. Even if one link or device fails, the data can easily reroute through other available paths. Because of this strength, mesh topology is widely used in internet backbones and data centers where uninterrupted communication is essential. The only disadvantage is that it is expensive and more complex to install because it needs many cables and connections. A real-time example is the global internet backbone itself. Major service providers like Google, Cloudflare, and Tata Communications connect their data centers across different countries using multiple fiber routes. For example, Google's data centers in India, Singapore, and the US are linked using several undersea cables so that even if one link fails, traffic is automatically routed through another path. This ensures the internet continues to work even during failures.
Now, let's move on to a very important network structure called the tree topology, also known as the hierarchical topology. Think of a family tree or an organization chart. At the top, we have a main head like your principal. Under the principal, we have vice principals. Under them, we have teachers. Under them, we have students. The same structure is used in the tree topology. How tree topology works? At the very top, there is one main device called the root node, like a main router or a central server. Below that, several intermediate nodes are connected. They act like a middle level routers. At the last level, the end devices or clients are connected. It is basically a combination of a star topology and bus topology. Devices are arranged in layers just like branches of a tree. Now, let's see about some real-time example in this topic. At the top level, we have Tier 1 ISPs large companies such as NTT, Tata Communications. They connect with one another and form the backbone of the internet. Below them, we have tier 2 ISPs. These are regional service providers. Below them, local ISPs. And then finally, end users like you and me. So the internet structures look like backbone to regional, regional to local, and local to users, just like a tree with branches growing step by step. Why tree topology is useful? Because it is very easy to expand, easy to manage, and perfect for larger networks. But if a higher level node fails, all devices below it may get affected. Next, we come to one of the most flexible and widely used topology called the hybrid topology. As the name suggests, hybrid means mixture. So a hybrid topology is simply a combination of a two or more topologies. For example, a company may use star topology inside each office but connect different offices using a mesh topology or tree topology. So it mixes different designs to take the advantages of each and reduce the weakness. Why use hybrid topology? Because it is very flexible, very scalable, very reliable, and best for larger networks like companies or cloud systems. This is why big organizations and ISPs prefer hybrid networks. Now, let's see one real-time example. Let me explain. Inside a big company like Amazon or Microsoft, anything, servers and computers may use star topology. Their data centers across different regions are connected using mesh topology so that the data never gets interrupted. ISPs use a mix of tree and mesh for reliability and speed. So the internet is actually a larger hybrid network that blends the tree structure, mesh structure, and star structure all together. And where this hybrid topology is useful means it is very useful in a cloud data centers and ISPs and in large corporate networks, internet scale systems, and complex distributed systems.
Now we will talk about what is the application of the network topologies. We will know what is the network topologies. That means the structure or the layout of how the internet is interconnected to each other. It is used in the many real-life environments and experiments that depends on the cost, speed, reliability, and also the scalability needs. First application of the network topology that defined as bus topology, which means it is easy to connect the 5 to 10 computer system to each other at the same time accessment, and also easy to install, cost effective. And another one is the laboratory uses. Many colleges and school and institutions install this type of the topologies for easy to communicate with each other and the education purpose. And another one is podcast type communication. One to many transmission is used in this system by the network topologies because the one system is easy to operate the other many computers by the user. And another one is temporary networks. That is the rare network communication because the events, exhibition, and the election commission only this access, but it is a simple design and easy to access. And another application of the network topology is defined as star topology. It is most commonly used in the modern lands. The corporate offices, schools, colleges easy to use this type of the network topologies. And home, small business Wi-Fi networks, the Wi-Fi would act as a central node or the source node by accessing whatever will be Wi-Fi will be expected from the network. And another one is bank networks. The high reliability needed for Starbucks best because one system failure won't stop others. And another one is call centers. We well know call centers have the large number of systems connected to the central hub. So easy to access the what is the network will be expected from the topologies. And the application of the network topology is defined as the another one is ring topology. It is used where the data must travel in orderly and predictable way. The application of the ring topology is maximum cover for the network connections. For example, token ring networks, which means IBM used it widely in older corporate networks. But the advanced version of the MANs, which means metropolitan area networks, the some cities have the Y networks. So that is the reason only we use this type of topology in the network communication. It is easy to predict whatever will be the saddest news perform in that place. And another one is telecommunication networks. The SONET HTS links is used the majority in the telecommunication networks. The optical fiber system sometimes use the ring for fault tolerance. It's easy to connect whatever will be mistake perform as it is. And the another application of the network topology is mesh topology. Mesh topology is the maximum reliability and zero downtime is requirement. For example, military communication network, which means the fail news does not be communicate with each other, easy to connect whatever will be the person is say to and the opposite side. And high security government agencies, that means confidential and also the security communication. And another one is backbone networks of the ISPs. ISPs is the internet service providers. Mesh ensures the ISPs it's one link goes down. And the disaster management, reliable communication during the emergencies. For example, fire accident or the flood or also the earthquakes, whatever will be the sad news occur at a specific place, easy to communicate with each other by using this network topology. The another one application of the network topology that's defined as tree topology. Tree topology is used in the large hierarchical networks because it's an organizational structure. We well know the tree is a structured and is linearly organized the all data, whatever will be given from the user. And the application for this the tree topology is very larger because the university and the large campus networks use this type of the topologies, and also the corporate organization have the many branches and with the one head office also use this type of the topologies. And cable TV distribution networks, telephone networks use this type of topology for easy to connect with each other. And the last one of the application of the network topology, that is hybrid topology. It's a most real world networks use the combination of the topologies. Easy to access the hybrid in the topology network, the advanced version of the India version. For example, large enterprises network, the mix of star plus bus plus ring, the according to the department needs. The data centers, which means the star for racks and the mesh for the backbone communication, easy to access by the hybrid topology. And the campus wide networks, which means the hybrid model handles the different buildings and zones. So the hybrid topology easy to access whatever will be from expected the network and the user. The smart city networks, which means uses the various topologies for the surveillance, traffic, Wi-Fi sensor. And the network topology is the hybrid topology. It is the most common uses for the topology side and also the advanced India version.